Welcome to another edition of ProSoft Technology video training. Serial networks are the simplest way to send ones and zeros over a wire. A robust and efficient serial network is the result of good planning and proper installation. In this video, we will cover the design and installation considerations of setting up an RS485 serial network. Serial communications come in a variety of different physical standards, RS232 and RS485 being the most common in industrial environments. Unlike RS232, which is a point-to-point short-distance network, RS485 can support up to 32 devices in a half-duplex multi-drop configuration. It can also support communications up to 4,000 feet, or 1,200 meters, and support baud rates from 110 to 115.2 K. The communication range can be extended even further with an RS485 repeater. As a result, RS485 has become the basis of the most commonly used industrial automation communication protocols, like Modbus RTU, Optimux, Profibus DP, and DH485. The wiring for RS485 comes in two flavors, 2-wire, which actually uses 3 wires, and 4-wire, which actually uses 5. In each case, the extra wire is the signal common, and we'll talk more about that later. In a 2-wire network, the transmitter and receiver of each device are connected to a pair of wires, positive and negative. 4-wire networks have one master port with the transmitter connected to each of the slave device receivers on one pair of wires. The slave transmitters are all connected to the master receiver on a second pair of wires. The 2-wire systems are more popular, but which flavor you use will depend on the devices and protocol that you want to use. In both types of networks, each device or node is addressable and can be communicated with independently. The ideal layout of an RS485 network is a daisy chain architecture, with the master device located at one extreme end. This tends to minimize the possibility of signal collision. Star, T-drop, or ring-type topologies are strongly discouraged, as they can cause serious communication problems. In industrial environments, the problem of electrical noise being picked up on the transmission line can constitute a serious challenge to wired communication. For best results, use twisted pair cables for the signal pair. By twisting back and forth, the noise current generated by external interference affects the signal levels in both wires in roughly the same way, effectively canceling itself out and leaving the voltage difference on each line largely unaffected. This is what gives RS485 its impressive range. On a network with proper topology, you only need termination resistors at the two extreme ends of your network in order to prevent signal reflection from an open circuit. Some devices have a resistor built in. If you use such a device and the resistor is engaged, it should only be placed at the extreme ends. If your devices do not have built-in termination, note that the value of each resistor should be equal to the characteristic impedance of the wiring, typically 120 ohms for twisted pairs. Another fundamental problem of wired electrical communication is that the Earth has different potentials at different locations. The ground potential on industrial sites can be vastly different. Ground potential differences of more than 12 volts could possibly damage an RS485 port. To solve this problem, or at least fight against it, RS485 networks utilize a signal common wire and a shield ground. The signal common wire runs, along with the signal wires, between each node on a network. It provides a common reference potential level for the RS485 nodes, which otherwise carry floating voltages. The signal common ensures that each device will have the same 0-volt reference and will not inadvertently exceed the voltage limits of the hardware while transmitting data, because of potential level differences in the transmitter and receiver locations. It's also typical for communication lines to have a shield, a thin metallic jacket encasing the signal wires that is conductive and grounded. The shield ground is a notional infinite charge sink that allows the shield to act as a Faraday cage, keeping out external electromagnetic interference from disturbing the signals in the communication wires. Even though twisted pair cables largely negate the effects of external interference, it's still good practice to use shielded cables. When wiring up your network, use the common signal reference cable to tie the ground potential of each port to the same ground. You should also ground the shield at only one point in the network. If the shield is grounded at several points, you may get ground loops, current flowing through the shield, and this will induce noise on your signal wires. Speaking of inducing noise on your signal wires, when setting up cabling for your network, be sure to run your signal lines in a different conduit than your power lines. There are limits to how much electrical interference a shielded twisted pair wire can negate. Keep in mind that not all manufacturers label their wires the same. If your ProSoft master device constantly transmits but receives no reply, try swapping the two signal wires. There's no real standardization for the labeling of RS485 signal wires, so this is often the source of communication problems. If you have an RS485 4-wire network but want to use a 2-wire device, you can simply tie the two positive signals together and the two negative signals together at each device, and you'll have a 2-wire device communicating over 4 wires. All types of industrial cables are not created equal. Be sure to use the correct cable for optimal RS485 performance. This is a 120 ohm nominal impedance cable, such as the Belden 3106A industrial cable. These are some of the basic considerations and tips that you should keep in mind for an RS485 network. If you would like more information or technical assistance, don't hesitate to contact us.